Dear friends, I'm Abhinash from Pilot 18. In this video, we are going to learn about radio waves. Okay, and radio navigation is one of the part in the navigation syllabus for DGC exam. So let's get started with radio navigation. So as an overview, radio navigation is all about instruments which are used using radio waves, such as GPS, all the instruments like DME, ILS. There are so many instruments which helps us in landing, flying, and to report position. So those all instruments basically works on the basic of radio waves. So to understand that, we need to understand the basic properties of radio waves and so on, right? So in this video lesson, we are going to learn about the overall basics of radio waves, which is essential to understand the avionics radio instruments, right? The radio instruments which we're using for flying. So let's get started. The first thing is radio waves. How radio waves are generated, right? So radio waves are basically electromagnetic radiation. They call us radio waves or EM radiation or electromagnetic radiation. So to understand the basic how a radio waves are generated is, let's take one metal rod and a battery with positive and negative. If you connect the positive and negative to the metal rod, there will be a current flow in the metal rod, right? A conductor. In this metal rod, we are going to consider this metal rod as antenna now. Okay. So now, antennae, right? So now, if this battery positive and negative connected to a metal rod, there will be a current flow in the metal rod, and when there is a current flow, there will be a magnetic field, right? So that's what the properties of current. Whenever there is a current flow, there will be a magnetic field set up in a 90 degree to the electrical field. So if I send the current in this direction, there will be a magnetic field set up at an angle perpendicular to the electric field. Magnetic field and electrical field are perpendicular to each other, right? So this is in the case of direct current. Battery gives direct current, which means the current flow does not reverse. The current will be flowing only in this direction, negative to positive and so on, right? And there will be electric field in the metal, and due to the electric field, there will be a magnetic field produced in perpendicular to the electric field, right? So, but what happens when you correct alternate current to the same metal rod using a generator, right? If you connect the same here, what happens? The property of alternate current is reversing the direction. Alternate current does not travel in one direction. In 1 second, 60 times in our home appliances, the current which we are using at our home, 60 times, either it is 50 hertz or 60 hertz. 50 times to 60 times in 1 second, it reverses the direction. For example, this is positive and negative, means there is no positive and negative actually in alternate current. So let's not get into the electrical topic. Here, it travels in one direction. DC current, battery, alternate current which is produced using generator, in 1 second it goes and comes rapidly like this, right? The direction keeps on changing. When the direction keeps on changes, what happens? There will be a kind of fluctuation in electrical and magnetic field. So those fluctuation helps the current actually travel outside in the form of radio waves, right? It's like if you keep on touching some object, it will not vibrate. If you touch and leave rapidly, the object will vibrate. Vibrate as in the form of waves. There will be a vibration. Vibration is in the form of waves. That's what happens here. When you apply a constant force in one direction, there won't be any waves formation. Only the field will be formed, right? Magnetic field. But when you rapidly apply and release like a alternate current, you give a current, then stop, then another direction, give, stop, another direction. When you continuously do this, there will be a radiation formed, and the radiation is known as electric waves, right? So electric waves is produced due to the alternating current, rapid change of direction, right? Like how in the wire we had electric and magnetic field, which is perpendicular to each other. Likewise in this direction and this direction. Likewise radio waves also having two fields, electric and magnetic field. Okay, so two fields will be, they are perpendicular to each other. This is in horizontal plane and this is in vertical plane. Now there is a term comes polarization, right? Polarization means depend on which plane you are holding the antenna. If you hold the antenna vertical, then it is known as vertical polarization. If antenna stands vertical, it is vertical polarization, and the electrical field will be vertical. So if I say my antenna is horizontally polarized, which means the antenna is kept horizontal and the polarization is happening in, and the electric field is going in horizontal, in the horizontal plane, and magnetic field is going in vertical plane. That's right. So that's what polarization means. By saying either it is horizontal polarized or vertical polarized, we can say what is the plane of the vertical plane and how does the antenna stands. Okay, so these two polarization also has different properties. Vertical polarization actually can send information for much longer distance comparing to horizontal polarization. So mostly vertical polarization are in used. So this is about radio waves and electric field, magnetic field and polarization, right? Next we'll see about the radio waves properties. Okay, first let's have the quick properties of radio waves. It travels at the speed of sound. Does not need any medium, which means when we speak, we cannot speak in vacuum, right? Because the sound waves need air molecules to travel, but radio waves does not need any molecules to travel. That's why we can even send the radio waves to space, and we are controlling our satellites. So these are due to radio waves have the properties of it can travel even in vacuum. It does not require any medium to travel. So it refracts, reflect, attenuates. Okay, it's like a light. When you light refracts, reflects and attenuate, which means attenuates means loss of power. So when you have a torch light and you switch on it, the light can go until only certain distance, depends on the power of the lamp. Likewise radio waves also can travel up to certain distance, depends on the power of the wave. Now next is reflect. It goes, hit the object and it comes back. Okay, like sound waves, it has the property similar to sound wave. Sound wave used to echo, right? In a closed room, if you speak, the sound actually gets echoed. The waves hit the obstructions and return back. Likewise, radio waves also hit the obstructions and returns back. So reflection. Next is refraction. This is one of the property of light. Like when you put a coin in a bowl of water, you actually see like the coin is a little bit far from the actual position, or in other words, you can just simply put your hand in a glass bowl of water. You can observe above the water, your hand will be comparing to inside and outside the water, your hand will be little bit displaced, right? So that's actually refraction of light. So radio waves also get refracted, which means bend. Actually it won't, if any obstruction kind of water or any kind of obstructions in atmosphere, there are a lot of obstruction like clouds, water molecules and ions. So many obstructions are there. So when radio waves goes through it, it actually refracts if it travels straight in a normal space, if there is some obstruction such as water molecules or something, the radio waves get refract and travel. It will bend. So that's what it is, refraction. Okay. So it travels at the speed of, I'm sorry, I wrote sound. Travels at the speed of light. The very important property, does not need any medium. It refracts, reflects, attenuate, and so many other properties. So these are the important properties of radio waves. And speed of light, we all know it's 3 into 10 to the power 8 meter per second. In other words, you can write 3 lakh kilometer per second or 1,62,000 nautical mile per second. So this is the speed of radio wave, which is very important. You must remember all the time. Okay, 3 lakh kilometer per second. Next, we are going to see what is wavelength, frequency, and frequency band. Okay. So now we know how to generate the radio waves. So let's see. Now we generated a radio waves. Radio waves travels in the form of waves like this. Electromagnetic radiation, basically. So they are forms in the form of waves, which is known as radio waves. Now, so it goes like this, right? And so on. So 0, 90, 180, 270, and again 0. So this is known as phase, the phase of radio wave. Radio wave travels phase, P-H-A-S-E. So now, so this is known as phase. Okay. So radio waves travels in the form of waves. We need to measure the waves in some method. The method which we use to measure the radio waves is phase. Okay, 0, 90, 180, 270, 360 degree, just like a 360 degree angle. Then it's so, and it keeps on going. Third, 180, again repeating, 90, 180, 270, 360, and so on, right? So this is known as phase. And from 0 to 0, one complete cycle. Okay, from 0 to 0 is known as one complete cycle. Understand? Radio waves travels in the form of waves. These numbers, measurement of the wave amplitude or measurement of the waves is done by phase, and phase value starts from 0 to 360, 0, 90, 180, 270, 360. In between all those numbers 1, 2, 3, 4, 5, 6 and so on, right? So the length of 0 to 0 is known as one complete cycle, and 0 to 0 is known as one complete cycle, right? Now the length of one complete cycle is known as wavelength. One complete cycle length is known as wavelength. Okay, and number of waves per second is known as frequency, and one complete cycle they call as equals 1 hertz. They call one complete cycle as hertz. We can't say every time one complete cycle, one complete cycle. So in order to make the unit simple, in order to make the explanation simple, we got a unit which is known as hertz. One complete cycle means 1 hertz. All right, and the length of one complete cycle is known as wavelength, which is known as lambda. And third one, frequency. Number of cycle or hertz per second is known as frequency, right? So number of cycle or hertz per second is known as frequency. So now what all the things? Wavelength, hertz and frequency. Wavelength means the length of one complete cycle is known as wavelength, and one complete cycle is actually known as 1 hertz, right? Or the length of 1 hertz is known as wavelength. Let's not take hertz in the wavelength, just length of one complete cycle is known as wavelength. and length is measured in maybe millimeters, meters. So we here in radio navigation chapter, we use the wavelength unit of meter. Okay, we use meter as our unit to measure the wavelength. From that we can convert to anything, right? And next is hertz. One complete cycle is known as 1 hertz, and frequency is number of hertz per second. Let's say in 1 second we have 100 hertz, 100 complete cycle. We call it as, my frequency is 100 hertz. Got it? I hope you understand this. So next we're going to see phase comparison. Okay. Now let's see the relationship between wavelength, frequency and all, right? So now F is equal to C by lambda. This is a frequency. Frequency equals speed of radio wave divided by lambda, and lambda equals C by F, and C equals F into lambda. Okay. These are the two formulas which we use in exams. This thing actually doesn't comes into part, but let's just simply keep it on the side. Let's complete the formula. Yeah. So what they ask is, in exam they will give you either a wavelength and ask you to measure the frequency, and either they'll give you the frequency or ask you to measure the wavelength. So F is equal to C by lambda. The unit we are going to choose in order to make the problem solving easy, we are going to use frequency in megahertz, C 300, because speed of light is actually 3 into 10 to the power 8 meter per second. But then if you keep 3 into 10 to the power 8 meter per second, then your frequency comes in hertz. Okay, and your lambda you need to make in meter. Then your lambda comes in some, if instead of 300, if you keep 3 into 10 to the power 8 meter per second, which is 3 into 10 to the power 8 meter per second, your frequency will come in hertz, and lambda comes in some micrometer something, so which makes the calculation lot more difficult. So that's why we created a simple method: frequency megahertz, 300 speed of light, and lambda for meter, wavelength meter, right? So meter megahertz 300. This is how I remember. Lambda in meter, frequency in megahertz, mic and 300, right? So now let's say we have a wavelength of 2 centimeter. Okay. Now 300 divided by, let's say 2 meter. I'm sorry. If you got the, in question they are given wavelength lambda is 2 meter. Find frequency. So 300 divided by 2, frequency is 150 megahertz. Okay. Now what is this megahertz? Now we need to see different type of frequencies available. Okay, let me write it here. The frequency band, this is known as frequency band. It starts from very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extreme high frequency. Alright. So very low, medium, high, very high, ultra high, super high, extreme high. So how I remember this is volume high, very useful. So it's one of mnemonic or acronym which you can easily remember the order. VLM, volume, H for high, V very, USE useful. Volume high, very useful. Okay. Through this mnemonic you can easily remember the order. Volume high, very useful. So very low frequency, medium, high, very high, ultra high, super high, extreme high, and so on. So we have seen frequency is actually measured in hertz, right? The length, number of cycle per second is known as hertz. So let's start with 3 to 30 hertz, right? sorry, 3 to 30 kilohertz, 30 to 300 kilohertz, 300 to 3000 kilohertz, 3 to 30 megahertz, 30 to 300 megahertz, 300 to 3000 megahertz, 3 to 30 gigahertz, 30 to 300 gigahertz. So even there are so many frequencies band before and before VLF and after extreme high frequency, but for aviation purpose knowing about this much frequency band is enough. So I would have taught this earlier before going to this. So let's see the frequency band now. Right? Hertz is, why there is no hertz we are considering in our frequency band is, hertz is a very low unit which we are not using for our in our avionics equipments. So we directly starts from kilohertz. So now we know what is hertz, number of cycles per second. So 1000 hertz actually equals to 1 kilohertz. 1000 kilohertz equals 1 megahertz. 1000 megahertz equals 1 gigahertz. It's like kilobyte, megabyte, gigabyte. 1024 kb is 1000 kb is 1 MB, 1000 MB is 1 GB. Likewise, okay. So 1000 hertz equals 1 kilohertz. 1000 kilohertz is 1 megahertz. 1000 megahertz is 1 gigahertz. Okay. Additionally, you must know how to convert from one hertz to another hertz. For example, convert from gigahertz to megahertz. Okay, that is one another method is there. You can write GMK. Okay, GMK, when you go down you need to multiply it by 1000, when you go up you divide it by 1000. GMK, when you fall you multiply, the speed will get increased. When you fall from somewhere the speed gets increased, so you multiply by 1000. And when you climb, climbing is actually done at slower speed, so you divide it by 1000. Division means if you divide anything by anything the value will be less, and when you multiply anything by anything the value will be more. So that's why while going down multiply, while going up divide. Okay, climbing is always slower. GMK, gigabyte, megabyte, sorry, gigahertz, megahertz, kilohertz. When you convert from gigahertz to megahertz, multiply by 1000. Megahertz to kilohertz, multiply by 1000. If you want to convert gigahertz to kilohertz, first giga to mega, gigahertz to kilohertz, megahertz, multiply by 1000. Whatever answer you get, then again multiply by 1000, you will get the kilohertz. Okay, if you want to find, you have kilohertz and you want to convert into gigahertz, first you convert kilo into mega, which is divided by 1000, then again divided by another 1000, you will get the giga. Okay, like this you can easily convert from one unit to another unit. Now let's see the relationship between frequency, wavelength and frequency. F is equal to C by lambda, lambda is equal to C by F, and C equal to lambda and F. Okay. So first question, wavelength lambda equals 2 meter. Find frequency. Okay. So frequency formula, F is equal to C by lambda. So what here we are going to keep is, let me give you the formula first. I have already given you frequency in megahertz, C for 300 speed of light, lambda in meter. Meter, megahertz, 300. Why? In order to make the problem easy, to calculate easy. If you keep 3 into 10 to the power 8, then you have to keep here hertz, which add up a lot of zeros, makes the and problem more complicated, and there are chances to get mistakes. If you miss 1 0, then the answer will come something else. So meter, megahertz, 300. So frequency 2 meter, lambda 2 meter they have given, so no problem, you just put 2 here, 300, and frequency in megahertz. So what answer you will be getting? 150 megahertz. Frequency is 150 megahertz. What if in the options they didn't give 150 megahertz. So now you need to look for gigahertz or kilohertz. So if you want to convert megahertz into kilohertz, you'll multiply by 1000, you add 3 more zeros and check for kilohertz. If you want to convert it into gigahertz, then it comes decimal 150, 0.15 gigahertz. That's right. So like this you can look for the options and solve the questions easily. Just a simple division, right? The units you must be look carefully, because in some question they'll give you lambda is 20 centimeter, wavelength is 20 centimeter. So what you need to do, you need to convert centimeter into meter first, right? Because the formula says lambda in meter. So 20 centimeter divided by 100, because in 1 meter there are 100 centimeter. When you convert meter to centimeter, you will multiply, and centimeter to meter you will divide. 20 divided by 100, 0.2, and you will add 0.2 here, and 300 divided by 0.2, which is roughly 1500 megahertz, it will come. Then if they give an option in megahertz, you're fine. If not, then you have to look for in gigahertz or kilohertz. Just easy multiplication and division. So that's about the conversion of that's about the frequency band and the conversion of lambda to wavelength into frequency or frequency into wavelength. Okay, so from this we can understand one thing: if the frequency increases, wavelength actually decreases. If frequency decreases, wavelength increases. Frequency and wavelength are inversely proportional. Okay, frequency increases, wavelength decreases. Frequency decreases, wavelength increases. Now let's see what all the factors. Now we are going to see phase comparison. Why we need to understand phase comparison means, because in the avionics radio instruments, the radio instruments which we are using for flying, there are not only one phase is coming out of the antenna. Okay, there are multiple phases coming out of the antenna in order to determine so many things. Okay, just one radio waves, just not only one radio wave is coming out of an antenna. It's like, I'm sorry, just not only one wave coming out. From one antenna there are multiple waves coming out, and they all work because of with the principle of phase comparison. There is a very important instrument which is known as VOR, which mainly works with the help of phase comparison. Okay, so we need to understand what is phase comparison. And the VOR instrument, it's a very old instrument and classic, which is still in use, and it's extremely useful, okay, for so many things that we'll see in the chapter. So yeah, phase comparison. So let's say a radio wave is transmitted from an antenna with more than an antenna is transmitting radio wave, more than one radio wave. Okay, so, and radio wave, how do we see the radio wave? Like this. And how do we measure phase? 0, 90, 180, 270. Okay, let's say there are multiple phases in it, right? Different there are more than one radio waves, so they are coming out in different phases. One radio wave is coming out at 0 phase, another radio wave is coming out at 90-degree phase, like this. Okay, so comparing the phase of one radio wave to another radio wave is known as phase comparison. What is the phase difference between two different radio waves? Let's take one example. Let's imagine this is antenna, and one radio wave is coming like this out of the antenna, and the second wave is coming like this. Okay, and so on. So now what we can see here, one is known as reference and the second wave is known as variable. Remember why we need to see the phase comparison? Because there are equipments which works due to more than one radio waves coming out of the antenna. Okay, so now we need to differentiate those two waves. To differentiate that, we need to know the phase difference or phase comparison. So there are two waves we take, one is reference, another one is variable. So reference starts at 0 and traveling like this, but you see the variable, it's not starting in 0, it's starting somewhere else. 0 is here, right? So now we need to know the phase difference. So to find the phase difference with the help of diagram, it's very simple. You start with the reference wave, go along, go and stop here. Why here? Let me tell you. It's better not to start with the reference, you start with the variable wave. Okay, you need to find out the starting point of variable wave. So when does the starting point occurs? The bottom point is always 270, right? This is 270. If this is 90, this will be 180 of the variable wave. This is bottom is always 270, right? So 0 is initiating here. Hope you understand. Once again, the reference is starting with 90. Okay, so 90, when I come down, it is 180. When it is topmost position, it is known as 90, right? So it can be 85, 86 or also, doesn't matter. It's coming from up to down, so it is definitely 180, that we are sure. When it is down, extreme bottom is known as 270. Here we call 270 for our reference. This is 90, reference 90, 0, and this is 180 for reference wave. That's right. So 180, 270, and it starts at 360 here. Okay, now you need to draw a straight line to a reference wave. So where does it touching? It touching at approximately 270. My diagram is a little bit here and there. In the printed diagram, you can easily find by using the picture. So step 1, find 0 of variable and connect with reference, and the phase of reference is phase difference, right? So step 1, I find 0 of my variable wave, 90, 180, the bottom is 270 and this is 0. So the 0 I'm going to connect with the reference wave. So here was my 0. If I draw a straight line which connect my reference at 270 phase, 0, 90, 180, 270, right? So 270 is my phase difference. My phase difference is 270. Alright, in mathematical term, the formula is reference minus variable. So phase difference formula is reference minus variable. So in exams, if you provided with the reference is 270 and variable is 90, then it's simple. Reference minus variable, you just simply subtract, you're gonna get the answer. And in some questions, it will be reference is 45 and variable is 270, right? So in that case, 40 minus 270 means you will be having answer of negative 230. So if the answer goes in negative, what you will do? There are total 360 degree phase in the radio waves. So minus 230 plus 360, you will have 130 is your phase difference, right? So likewise, either by mathematical way or by using the picture way, right? You can find the phase difference easily. So next we are going to see some of the factors which affect the properties of radio waves. Number 1 is attenuation. You can say factors affecting propagation of radio waves. So factors affecting radio wave propagation. When you want to send some information from one place to another place, or no, let's come to the point later. When you want to transmit a radio wave, we know what all we need. Okay, there's a radio wave generator, antenna and so on. And when we want to receive, we need the same setup, a receiver here, right? So the radio waves travel, and whatever information we send, it finally goes to the receiver and we are receiving the information, right? But it's not as simple as it. There are so many factors which actually affects the radio wave traveling. Let's see one by one. Number 1, attenuation. Okay, attenuation actually divided into further two, which is absorption and inverse square law, right? Attenuation is basically loss of signal strength as the wave travels. So we know if the radio wave travels, there will be a loss of strength in the radio wave. But why? What is the reason? Number 1 is absorption. Number 2, inverse square law. Let's see what is this. First one, absorption means like disturbances in the atmosphere. It can be a solar flare activity or ions in the atmosphere. The best example is moisture. Okay, moisture, it's a kind of radio waves. It's actually electricity. So if you resist with something, the electricity flow will be disturbed. Likewise, in atmosphere there are lot of resistance such as water, moisture, clouds, dust particles, and in land there are rocks and so many things to block the radio wave propagation. So absorption, the first thing is absorption of power by, the main thing is moisture or water particles, H2O particles in atmosphere, right? Moisture, clouds and vegetation, which is plants, trees and all things, and mountains, these all things. Okay, anything which blocks the path of radio wave, right? So the main thing is moisture, because radio waves mostly we used to communicate in the air only, right, for the aviation purpose, and even for navigation purpose, mostly it going to send the radio waves to the air. So it gonna use air as the it going to travel via air. So in air, the main obstruction what we have is moisture particles. So this actually absorb the power, and not only moisture particles, clouds, mountains, trees, vegetation, everything absorbs the radio power. Okay, so the strength actually weakens as it travels. And next one is inverse square law. You can imagine a light. So when you place a light, right, in a room, the light spreads until some certain direction, certain length. Let's say a bulb, when the bulb glows, it lights up to a certain place. So as the distance increases away from the bulb, what happens? The light gets dimmer and dimmer, right? So if you want to light up more space, you need to have more powerful bulb. Okay, that ratio is actually in a square. So let's see what is that ratio. To double range, you need 4 times the power. Okay, this is inverse square law. According to this law, your power requirement will be 4 times if you want to double the range, right? you can imagine the light bulb in a room. If you have a light bulb in the room, what happens? It glows unto a certain range. After that, it becomes dark. So if you want to extend beyond that range, you need to have this ratio. If you want to double the range, you need to increase 4 times the power of radio waves. Then you can get double the range. But there are alternate ways also that we'll see in the different types of antenna. Okay. So inverse square law, yes, we have seen. So attenuation definition, many times it's been directly asked in the DGC exam. What is attenuation? Loss of signal strength as it travels outside. So next other things are fading. Fading, in other words, you can say it's not working properly. So what all the factors which can contribute to the radio waves not to work properly? Number one is reflection, refraction and all things. Okay, we were talking about fading. Fading means it's a kind of disturbance which will not make the radio waves to work properly. For example, if I have a transmitter here and I have an aircraft here, right? So I want to send information from this transmitter to my aircraft at this space. So if there is a mountain here and there are chances it will hit the mountain and jump to the aircraft. And if there is a disturbance in the atmosphere such as moisture, it will refract and go to the aircraft. So now it's causing a disturbances, right? So the information might not reach to the aircraft properly due to the reflection and refraction. This process is known as fading. And there are some extreme cases where you will not receive any information. Both the waves, they reach in opposite and they cancel out the phase and you won't receive any information. Okay, so that's fading. And other factors which affects the ranges, sensitivity of the receiver. If the receiver is more sensitive, it can even pick up the weak signals and the range can be increased. Okay, because we were discussing about the factors affecting the range, like factors affecting radio wave propagation. So now attenuation we have seen, fading we have seen, now receiver sensitivity. If the receiver is more sensitive, then even though if your transmitted signal is weak, you can capture the signal more better, right? Third one, directivity. So which we were discussing about the bulb earlier, in the range of radio waves, the maximum distance where radio waves can go up to, the range of radio waves, yeah. So one was just a bulb, so it could cover some area in all the direction, right? Now imagine a torchlight. The torchlight actually has a setup something kind of like this. So this setup will glow the light in a particular direction for a longer distance. That is known as directivity. So if you want to increase the range of the radio waves, instead of transmitting the radio waves in all the direction, you just put a parabolic reflector or something like that and direct the radio waves in a particular direction so that the radio waves can travel for the more distance. Okay, and in olden times there were antennas like this, like a kind of needle. So these are the rods which actually use like a reflector so that they can transmit for a longer range and they can also pick up the weaker signals as well. So directivity, these are used for directivity, right? And in parabolic antenna, it's actually uses in reverse. Instead of sending in a particular direction, the parabolic reflector, what it does, it attracts radio waves from all the direction, then it gives to the receiver. So this is parabolic antenna. So that's why we keep the parabolic in our dish TV, right? The best example. Directivity means sending in one particular direction, right? So that we need less power, The same thing we can use it on the receiver also, to receive signals from a wider space and take it back to the center and give it to the one particular point, right? So this is the focal point of the receiver, right? And so on. Let's not get into much over there. So basically this is the concept. Directivity, sending radio waves in one particular direction, so that you can increase the range. You can send your radio waves to more distance. So next we're gonna see types of radio wave, right? What all the types of waves are there? No, before that let's see types of antenna. First one is half dipole aerial. Second one is Marconi or Macroni. I don't remember what was the second type. Idu konjam cut panna vendiyadu varum. Half wave Marconi. So let's see the types of antenna. Number 1, half wave. Number 2, Marconi or quarter wave. So these two type of antennas, and another third one which we use in is slotted antenna or flat plate antenna. So half wave means your antenna size should be half of the wavelength, right? Because radio waves, they have every particular radio aid equipments, they have some fixed frequency band. Within that only they operates, right? So if they operate in a fixed frequency, which means the wavelength is also going to be fixed, right? So whatever the wavelength may be, 50% of the antenna size should be 50% of the wavelength. Those type of antennas are known as half wave antenna. And another type is also there, which is known as quarter wave or Marconi aerial. So these kind of aerials, they have a quarter size of the wavelength. If the wavelength of the radio wave is 1 meter, then the antenna size would be 0.25 meter. And the third is slotted antenna or flat plate antenna. These type of antenna we use for our airborne weather radar, which we discuss later in the topic. That antenna actually looks like something like a flat plate in front of the antenna, and they have a small slot in it. So that's why they call it as either slotted antenna or flat plate antenna. These kind of antennas are more advanced, so they just send signal only to the particular direction, okay? And these can be even controlled. How much area you need to send the radio signal, or how much area you need to cover with the radio waves, can be controlled with the slotted antenna by giving variation of power inputs to this, okay? So that's why this is more efficient, right? So, and it also has directivity. You can choose the direction where you want to send the radio waves by using this antenna. So you are using the radio waves in a particular direction, which is directivity concept. So you can increase the range of the radio waves, right? So that's known as slotted antenna or flat plate antenna. So let's not get into much into this, because just knowing is sufficient. Next type of waves, right? There are three important waves: surface, space or direct, third one sky wave. As the name itself says, surface wave, which means the radio wave will travel over the surface, right? So now, at what frequency does the wave travels through the surface? The frequency band is approximately 20 kilohertz to 50 megahertz. Right? Within this frequency band, there will be a surface wave. Wave will be traveling over the surface. Next is space wave or direct wave. Above VHF, the wave will be traveling from point to point. If you want to contact an object to a point to point, better to use space wave. And when does the radio wave travels in the form of space wave? When your frequency band is above VHF. Okay? VHF is VHF and above. So that is 30 megahertz. So above 30 megahertz. So within this frequency band, like surface wave is 30 to 50 and space is direct is 30 megahertz and above. So within this 30 to 50, these narrow band, there will be both surface wave and space wave. Okay, surface wave will also be there, space wave will also be there. Next is sky wave. Sky wave, let's discuss it separately. So you understand, surface wave travels along the surface, space wave travels from direct, one point to another. In other words, line of sight. Right? And the surface wave range depends on 3 into square root of power in watts over C. If you send it over C, range equals 3 into square root of power in watts over C. And if you want to measure the range in land of the surface wave, then it is 2 into square root of power in watts. Right? And for space or direct wave, there is a formula, 1.23 multiplied by range equals, very important formula. You need to use this almost all the times in your radio, in the radio part of the navigation exam. Open bracket, square root of height of tower transmitter in feet above mean sea level plus square root of height of receiver in feet above mean sea level. Okay, by this formula we can calculate the range. In question they will be asking you such like your height of the transmitter is 1000 feet above mean sea level and you are flying at 100 feet above mean sea level. So what is the range of the aircraft? It comes approximately 90 miles when you calculate this. Okay, 1.23 into open bracket square root of transmitter in feet above mean sea level plus square root of receiver in feet above mean sea level. So with the help of this formula you can find your the maximum range where you can communicate with the ground or aircraft to ground communication when you are using the space wave or direct wave. This is also known as line of sight. Okay, so when you are using VHF and above radio wave for the communication or navigation requirements, if you are below this line of sight range, you will get no signal. Let me draw one small diagram so that you will understand. If this is Earth, right? Now the transmitter is here and the aircraft is here. Now if I send signal, I cannot reach the aircraft because it is below my line of sight. Space wave or direct wave, it just travels direct. So if I want to catch the signal, I have to fly higher, right? So if you are more distance, this is transmitter and this is receiver or aircraft. So if you want to receive the signal for a longer distance, you need to fly high. Okay, So, or you have to be above the line of sight. If you are below the line of sight, you will receive nothing. Like how when the sun sets below line of sight is the maximum distance which we can see. If the sun sets below line of sight, there is no light over the earth. It becomes darkness for a particular region. Likewise, this works. If you are below the line of sight, then you receive nothing, radio waves, when you are using space wave. Okay, let's come to sky wave now. So sky wave is basically, it occurs mostly in the frequency band of HF, right? So let's see what is sky wave. We have a transmitter, right? And we have a aircraft here. So if it would be space wave or direct wave, it sends the wave directly, right? But if it's a sky wave, what happens is the radio wave travels like this and gets refracted here and comes back, going to the sky and returning back. This method of communicating using such kind of wave is known as sky wave, right? So now here it's actually getting refracted. Why it is getting refracted? Because it's supposed to go straight. Why it is getting refracted is because of ionization layer. There is a layer called as, this is sky wave, ionization layer. So there is a layer in the atmosphere at the upper level, 60 kilometer to 1500 kilometer. So in that the pressure is very low, so the atoms are widely dispersed. Okay, so when sun heats it up, the atoms will get charged. Okay, like a solar panel, they will get charged and they will disturb the incoming radio waves. If there is no ionization layer, the radio waves will just go to the space. Because there is an ionization layer, which is a disturbance due to solar activity, the disturbance will cause the radio wave to refract. Okay, an ionization layer, it has D layer, E layer, F1, F2. Okay, D layer starts at 75 kilometer and F layer, it's at approximately up to 225, I guess, not exact, 225 kilometers, yeah, close to 225 kilometers. So we have understood this ionization is happening due to sun, because when sun heats up, the ions get charged like a solar panel. Okay, imagine a solar panel is located between 60 kilometer and 1500 kilometer, and these panels, this layer is known as ionization layer. So here solar gets heated, due to incoming solar radiation, the atoms get heated up and it will refract the radio waves. So those areas 60 kilometer to 1500 kilometer area, they just divided into 4 categories: D layer, E layer, F1, F2. As the sun gets, like in summer, during summer will receive more solar radiation, so the layer used to be at more higher, up to 225 kilometer. If it is winter, then it will be approximately up to 150 kilometer, and even 75 to 150 kilometer. And D layer actually forms during day. At night there is no D layer, because night there is no solar radiation, so night there is no D layer. So basically what by this we are trying to understand is, during summer and day the ionization is strong. During winter and at night the ionization is weak. Okay, that's what we are trying to say. So during summer the extends up to F2, 225 kilometer, and winter there won't be F2, and during day there will be D layer. The ionization starts at 75 kilometer itself, and during night there won't be. And at equator the ionization is strongest, because equator always receives strong sunshine. At poles sun it's very cold because the incoming solar radiation is very less over there, so ionization is less over near the polar regions. Okay, so ionization is strongest in summer, day, and during at equator. Okay, summer, day, and equator, and weakest in winter, poles, and during night. Yeah, that's all. So now let's get back to the sky wave. We understood why the refraction is happening due to ionization layer. Now there are some things we need to understand about some words, some definitions. Number one, critical angle. Number two, skip distance. Number three, dead space. Okay, so this is my vertical plane, this is my transmitter, and this is my vertical plane. Okay, when the radio wave starts travel, radio waves actually travels in all the direction, right? When the radio waves at the initial it was traveling in this way, it would have gone escaped. There is one angle, at the particular angle only, for the particular time, at the particular angle the radio waves will get refracted and come back. Okay, not always at the same angle, because the refraction is depends on ionization, and ionization depends on season, latitude, and day or time of the day or night of the date, right? So because of the ionization changes, the angle at which the wave come back also changes, right? So first I was transmitting my radio wave in this direction, let's say it's not coming, then slowly I increased, then at this angle I received the sky wave for the first time. So that wave is known as first returning sky wave. So I want sky wave, so what I did, I transmit radio waves in the vertical direction, then I checked, there is no return, then 1 degree I increased, then slowly I increased. At certain angle I will get my first sky wave, that is known as first returning sky wave. The angle at which first returning sky wave occurs is known as critical angle. Okay, angle between vertical and the first returning sky wave. Next, see now skip distance from here to here, the distance. This is aircraft where it is, so the radio wave actually travel from here to here. This distance is known as skip distance. Now remember, earlier we have seen surface wave, sky wave, and space wave. No matter whatever waves you are trying to send, surface wave will always be present, you cannot avoid it, right? So even in this case, when you're trying to get the sky wave, there will be some residual surface wave, but they will attenuate soon. Okay, because they are traveling over the earth, and earth is full of rock materials, they absorb the power from the radio waves, so they will easily attenuate and vanished at a shorter distance. So let's say my ground wave is ended up at this point, and my sky wave I got here. So within this region I have no signals, so this is known as dead space. Okay, so these kind of definitions you actually you will be asked in a DGC exam. What is dead space? This place where no ground wave and no sky wave is there. And what is critical angle? The angle at which the first returning sky wave is produced from the vertical plane, measured from the vertical plane. And what is first returning sky wave? When the waves at a certain angle, the waves refract and comes first. The wave which comes first is known as first returning sky wave. So about sky wave definition you won't be asked much. The main dead space and skip distance, they try to confuse you with this. Okay. So next is Doppler principle. So far we are just seeing the overview of the basics which would be required in order to understand the all radio aid equipments, right? So now let's see Doppler principle. So Doppler principle is actually what? A change of frequency when you travel, when there is a relative motion between two different objects. Let's see, now there is a transmitter here and there is an aircraft here. Okay, so now when the transmitter transmits radio wave, let's say 100 megahertz, and the aircraft is standing on the ground, or let's say a helicopter. Okay, it's just standing still, hovering, right? So whatever the radio wave I sent, it will come back to me at the same frequency, going also 100 megahertz, coming back also 100 megahertz. But if a relative movement, if the helicopter is approaching near me, when it was standing still, transmit frequency equals received frequency. Okay, now let's see, what if the helicopter is coming towards me? If the helicopter comes towards me, so this is helicopter, let's see, if this comes towards me, my frequency will actually increase. If it goes away from me, the returning frequency will actually decrease. So this is known as Doppler effect. Okay, the best example is when you're standing here and there is an ambulance. Okay, just simply, when the ambulance is far, you will hear the noise slowly, right? As the ambulance comes near and near, what you get, you will feel that the noise is very fast and loud. Okay, so that's the reason, because when you get closer and closer, the frequency increases. When you stand still, no increase of frequency. And when the same ambulance is going away from you, initially the noise will be like very quick and loud. As it goes distance, the noise will get slower and also quiet, right? Not slower, it will be quiet, and the noise will be slightly sluggish. As it gets closer and closer, the noise will be very fast and loud, and when it goes away, the noise will be a little bit sluggish, and the tempo of the sound will be slightly sluggish, and the noise will be also reduced. So that's what here, the frequency. So when you are standing still, frequency is same. When you approaching closer, frequency increases. When you're going away, the frequency decreases. So with the help of increasing and decreasing of frequency, the ground people can able to calculate the speed of the aircraft. Okay, using this frequency shift. The change of frequency due to movement is known as frequency shift. Using the frequency shift, there are a lot more things can be calculated, but the basic thing they can calculate is the speed of the moving aircraft which is coming towards you, right? So that's all about the basic of radio waves. And yeah, one more thing we have left, which is known as modulation. There's nothing much in the modulation, just the basic definition they ask. So let's see and finish the basic on introduction of radio waves. Okay, modulation. Modulation means method of adding information, right? When you want to send some information from one place to another, basically we are using radio waves such as mobile phones, voice. When you want to transfer your voice from here to another place, you are using radio waves, because radio waves can travel at the speed of light and so many properties it has. So basically to transfer information, we are using radio waves. That's what we have seen so far. Now simply sending the radio waves doesn't really matters, right? So you want to use the radio waves to send some information. So how do you send information? You need to add the information in the radio waves. So adding information in the radio wave known as modulation. You need to know there are two types: frequency modulation, which is known as FM, and second, amplitude modulation, which is known as AM. Okay, we just need to see what is AM and what is FM. So frequency amplitude modulation means, so this one, frequency modulation, this is amplitude modulation, this is frequency. Frequency modulation means frequency is number of hertz per second. If the radio waves are like very close, more frequency. If it's like this, less frequency. This is same amplitude. Amplitude is same. Amplitude in terms of radio waves, you can simply imagine the height of the radio wave. If height is constant, the amplitude is same. And here, if the radio waves are closely packed, high frequency, if widely spaced, it is low frequency. Okay, now let's see what is modulation. So modulation means, let's imagine the phone call. I want to transfer my voice into the radio wave, and the radio will take my voice to the other end when we speak phone. Okay, frequency modulation, that is amplitude. So now when I speak, my sound is also like a wave, right? So what I am going to do, when and this is the normal radio wave. Normal radio wave will look like this, and my sound wave also depends on the way I speak. The wave will get changed. Maybe it may like this or like this. It can be however it wants, right? This is my voice, and this is radio wave. So now I am going to change my, let's see first FM, okay, frequency modulation. My amplitude, you see the height of my radio wave, my amplitude of audio wave is going to modify the frequency of radio wave, is known as frequency modulation. Earlier the frequency was like this. Now my voice, amplitude of my voice is going to change the frequency. Then it looks like this. The place where I add the voice in the frequency, in the radio wave frequency, it looks more frequency, then later on it comes to normal. So whenever I speak, the frequency will get increased and then it goes back to normal. So you can see the 2 points, the frequency is increased. So these are the spots I imposed my voice into the radio wave. So my amplitude of audio wave modifies the frequency of radio wave, is known as frequency modulation. Amplitude of audio wave modifies frequency of radio wave. Next is amplitude modulation. It's very simple. Amplitude of audio waves modify the amplitude of radio wave. So if this is my voice, it can be like this, like this, like this, or anyways like this. And now this is my frequency of radio wave. So now look at the amplitude of my voice. My amplitude is going to modify the amplitude of radio wave. So now after imposing my voice into the radio wave, the modulation looks like, initially it will be small, then it will be big, then again it's small, big, something like this. Okay, because my voice modified the amplitude of the radio wave. So I put my voice by changing the modulation of the, when I put my voice into the radio wave gets changed its amplitude. Those kind of modulation is known as amplitude modulation. And when the amplitude of the voice, which is audio frequency, modifies the frequency of radio frequency is known as, frequency of radio wave is known as frequency modulation. When amplitude of audio wave modifies the amplitude of radio wave is known as amplitude modulation. That's all. So we have done with the basics. In the upcoming videos, we'll be looking one by one radio aid instruments such as VOR, DME, ILS, GPS, secondary surveillance radar, and so on.